Welcome to part 7 of repairing a 2-inch scale Fowler traction engine, showing the method that I used to repair the broken cylinder drain lever, followed by piping the live steam injector and repairing some of the damaged paintwork. This video shows a collection of very small, simple jobs, or so you would think. They do take an extraordinarily long time to complete. This clip shows the repaired cylinder drain. It's the one on the right hand side. This had been broken for a while and someone had used epoxy resin to fix it. My fix is a bit more permanent. The operating arms of these cylinder drains were both originally identical. The inner parts that rotate are made from brass, squared at the end with a 10BA thread, but a 10BA nut on a 10BA thread on brass is not going to last forever. Quite a lot of the bolts on this traction engine are very tight, and I think someone over-tightened the bolt on the right hand side and sheared it off, hence my repair. The problem for me with this job, as the parts are so small, was actually filming it. I did try it, but everything was in the way, so I thought I would just show you the principle. This is a small vise that I have with a very useful V up the middle, and in this V I'm fitting a piece of brass bar. Even though this piece of brass is a lot bigger, it illustrates how I fixed the top of the cylinder drain. I used a hammer like this to peen over the edges. This video clip is running at twice normal speed, and you can see how the more hammer blows I apply, the more the part flattens out and starts to extend outwards. The hammer blows are many and quite light, and after a while the piece of brass looks like this. Back to the job now, and this clip shows the finished repair. After the peening operation, the arm was quite a good fit on the shaft, but a belt and braces approach of a bit of solder never goes amiss. Once I'd fixed the arm, I put the rod back in place, and instead of the piece of bent wire through the bottom linkage, I used a 10BA nut and bolt. And as you can see, both of the cylinder drain valves work perfectly. Over now to a job at the other side that will take an extraordinarily long time. I'm going to pipe the injector. This is a steam inlet pipe that goes from a valve on the turret to the injector itself. Everything is in the way. The wheel is in the way. If I could take the wheel off, it would be good, but it's a bit impractical. I'll just have to do it the hard way. Eventually, I managed to engage the threads of the pipes on the inlet and outlet to the injector. And here I'm fitting the union nut onto the tap on the turret. These union nuts are very small, and it's all too easy to cross-thread them. So if you're doing a job like this, take care. Take it easy, make sure that the thread turns by hand before you apply a spanner. The spanner sat in the tray on the back head of the boiler is not my doing, it belongs to the owner, and this is far too big for anything to do with a model like this. I use my 4-inch Barco spanner, and I get a lot of criticism for doing this, but before you criticise, buy one and try it. The only disadvantage of an adjustable spanner of the quality of this one is its physical size. But because these spanners have very wide jaws, they do not mark the nuts. Here I'm using 2 of them to tighten this union halfway down the steam pipe. The marks to the existing fittings were already there. Sometimes it's not possible to use an adjustable spanner just because the space available doesn't allow for it. That's why I'm using a normal spanner for tightening the nuts onto the injector itself. This job took a lot longer than I thought it was going to do. Just engaging the nuts onto the threads of the injector took long enough. Once the pipes were connected to the injector, it wasn't in the right position, so I used a pair of pliers just to level it up. Now I need to make a special piece of pipe to fit between the union on the outlet tap and then to the inlet of the injector. First of all, I bent a piece of 3/16 of an inch diameter pipe to the right shape. The union at the tap end is a coned union, and it's not a good idea to tighten this fully before you try and fit the injector. This job drove me mad. It took quite a while to get the pipe to successfully engage on the thread of the injector. The injector doesn't have a coned union, it has a flat union, and unlike a coned union, this flat union doesn't help with the alignment. So the secret is to make sure both of the threads are slack, then you should be able to engage the thread of the union nut with the thread on the injector body. Once both the threads were engaged, it was time to tighten the nuts up. And once again, I much prefer to use my Barco with its wide jaws for tightening union nuts. Notice that it doesn't round any of the edges at all. Although I feel that I must mention that you need to have your thumb on the wheel to make sure the jaws fit up against the sides of the nut. I've used one of these spanners for about 45 years, so it's fairly instinctive for me. As I tighten up the nuts, everything moves into alignment. I'm only using the small spanner on the nut for the injector because I can't get the Barco in there. Looking at the clock on the wall of the workshop, I can't believe how long this job took. To complete the job, including the making of the water pipe, took over an hour. Although this does not automatically mean that the old injector that I've refitted is going to work, I'll be doing a steam test next week just to check out the steam side of things, and if this doesn't work, I'm not going to mess about, I'm going to replace the injector. The part that you're watching is just tightening this nut onto the injector, and because of the lack of space for moving the spanner, the amount of time that I had to turn the spanner over and re-engage was quite a lot. I think it's time for a bit of painting. I'd already painted this part of the bunker tank with etching primer, and now I'm painting it with some black enamel paint. I'm painting over the union nut that connects the water tap to the bunker tank on purpose, just to make it blend in. Obviously, I'm not painting the other brass parts. There is quite a lot of damage to the paintwork on this engine, so I'm just lightly and sympathetically touching in the paint. I rub the paint until the brush becomes quite dry, then it doesn't look quite as much like new paint. Once the paint has dried, it should look okay. I must mention that my brief for this job is not to repaint the engine as well, and there's quite a lot of work needs doing on the rest of the paintwork, but I think that's up to the owner, not me. The main job I've done is stop the knocking from the mechanical side of things. I spoke to the owner of this engine the other day on the phone, and while we were talking, he was telling me about some of the other problems that he never mentioned when I gave him the quote, so they're not included in the job. These are only problems with the pumps leaking slightly. If I can fix them easily, I will do, but looking at them, they're in very inaccessible places. Also, the engine is a little bit blowy. I'm not convinced that the piston is the best fit in the cylinder. Maybe the packings need replacing. But I don't really want to look at the cylinder at this stage. When running on compressed air, the engine appears to have plenty of power, and as long as it pulls him along, it should be fine. And that is it for this one. I'd just like to say, as I always do, stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.